Okay, so I'm going to first explain the GABAergic nervous response. So I've got two neurons here. This is the axon terminal of the presynaptic neuron, and then this would be the dendrite of the postsynaptic neuron. And then this together is the synapse, and this is the synaptic cleft. So inside the presynaptic neuron is a vesicle, and inside the vesicle is the neurotransmitter that we're going to be learning about first, which is GABA. Okay, so GABA helps you sleep. So in order to fall asleep, you need GABA to basically shut down some neurons so that your awake centers in your brain will shut off. So this basically needs to signal this next neuron to not fire. So that's the overall goal. Okay, so when the nervous impulse reaches the end of the axon, the first thing that it does is it causes these calcium channels to open. So this is a voltage-gated channel. So when the impulse gets here, this voltage-gated channel opens, and the calcium enters the neuron, and it binds to this receptor here called synaptogenin. And when that happens, this vesicle is going to cause these snare proteins to interlock. And when the snare proteins interlock, then the membrane of the vesicle will fuse with the membrane of the neuron, like this. And that will allow the GABA to leave the the presynaptic neuron and diffuse across the synaptic cleft, where it's going to bind to this gated ion channel. So this is a ligand-gated ion channel. So the ligand, being GABA, is going to cause this ion channel to open. Now this ion channel is specific to chloride, so these triangles are going to be chloride ions, and when they enter the postsynaptic neuron, because they're negatively charged, they're going to hyperpolarize the neuron and prevent it from firing. So that neuron won't be able to fire, and so that shuts down parts of the brain that make you awake, and so then you fall asleep. So that's how GABA helps you fall asleep. So in fact, GABA is in a lot of natural sleep remedies to help people sleep. So there's another drug that will also make you fall asleep. So when you go to have surgery, there's one of the types of anesthesia is propofol, and this is the structure of propofol. And so when the anesthesiologist wants you to fall asleep, he's going to just shut off your awake centers in your brain. And so what propofol does is it binds to this ligand-gated channel and just keeps it open. So without releasing GABA, it's basically short-circuiting that, causing the chloride to go in and shutting off the awake center. So that's the GABAergic synapse.